So we're happy to talk to Jerry Friedman today, who's about his gradient boosting paper and all the work that led up to it. And of course, gradient boosting is a hugely popular tool now in data science, and we fun to hear about how it came about. So welcome, Jerry.
Thank you. Thank you.
Jerry's actually upstairs in the same building we're in, but we're going to do it this way so that we can capture the conversation. So tell us how you got working on gradient boosting, the things that inspired it.
Well, what inspired it, of course, was our previous paper that the three of us wrote. That was in the Analyst, that the statistical view of boosting, which essentially everything in it, I thought was, and I think is a good landmark paper that showed that boosting was minimizing the loss function, et cetera, et cetera. So after we kind of finished that, I went off to Australia for a year's sabbatical. And I thought what I would try to do is put together all of the stuff we had done there into an actual statistical package. That's what I was thinking of. And one of the things that really caused me trouble with low-jip boost, which is one of the procedures we proposed for boosting, was the fact that it was always running into numerical problems because of the second derivative getting small, and it's in the denominator. And I would fix it up for one example, and then it would crash on another example, and I thought, boy, it would really be nice. So I kept putting tighter and tighter guardrails on it, and pretty soon I had the guardrails so strong that I basically wasn't using the second derivative. I was only using the gradient. And it seemed to kind of be working, and I thought, what if I can get rid of the second derivative altogether? And so that kind of what got me into trying to just follow the gradient. And so I realized, well, there were sort of three components. One was to realize that that stage-wise additive modeling could be viewed as stepping along a path in function space. The other being that you could always, if you have the loss function, and in the data, you can always kind of create a path through function space for any loss function. Okay. So what if we created a path in infinite dimensional function space for any function, and then approximated that by least squares? In other words, I had the function, which was, the gradient step, which is a function in the two variables. Now I can approximate that by least squares, with, for example, a truth. And so that was sort of the underlying idea. That you could convert a problem with any loss function into a least squares problem, and least squares problems are always the easiest to solve programmatically and even to analyze, but to actually solve, and especially for trees, because other tree-based algorithms based on other loss functions are messy compared to least squares, which is a tree. So that's how it got started, and that's how I worked on it.
Oh, we should sort of go back to remember the Freund-Shapiro paper that really got us all, introduced.
No, it was certainly not the first boosting paper, not close. Right. At the time, boosting had sprung on the scene with the AdaBoost algorithm.
Right.
And it seemed to work remarkably well.
But it was mysterious, though, wasn't it?
No one knew why or how. And there were a lot of papers trying to explain it. And it was designed for classification, and people were trying to generalize it with really crazy algorithms for regression. And so the issue was, there were a lot of papers, sort of a cottage industry of why boosting was working so well. And there were some increments. I think Leo was the first to suggest that the boosting was in fact minimizing a loss function, and which was an important clue. And of course, the other obvious important clue, which we exploited, was the fact that it was adding functions. So it was doing stage-wise additive modeling. It took us longer than it should have to kind of realize that.
Of course, Leo here is Leo Bryman, who was a longtime friend of yours and co-author, right?
Oh, yeah. In fact, I had collaborated with Leo for years. At this time, we were not working together. He went off on his random forest, and that's what he was. And I was putzing around in any number of things. But the main thing that led to this was, of course, our paper on statistical video boosting, which I think sort of totally exposed it, at least from my perspective.
But the students watching this who might not know, Jerry, of course, has been a long time teacher of ours and collaborator and a hero of ours, frankly. But what's novel about Jerry is you don't have a degree in statistics, right?
I do not. I probably will go down as the strangest hire in this department. Not only did I not have a degree in statistics when I was hired here, I had never taken a statistics course.
So Jerry's very good at thinking outside the box, partly because he doesn't even know what's in the box. Right? You start outside the box.
I can tell you kind of a funny story about that. I was very lucky when I first came to work with John Tukey. He was visiting SLAC at the time when I first came there. And he later returned about 10 years, I guess 7 years later on his next sabbatical. And whenever you would try and present an idea to John, he would sit there and listen to it. You'd be on the whiteboard marking it out. Okay. And he would sit there, and if he really liked what you were doing, he would stare straight ahead with a stern look. If he was not liking it, he would sit there with a stained look. But instead of looking straight ahead at you, his head would go back and forth like this. And if he really didn't like it, then he would do. So I got a few. I got some straight looks, but I got a few too. Well, anyway, this was the second time we visited, and we were driving on Campus Drive, and I had just received my appointment in the statistics department. And so I would say, you know, John, I'm going to be a professor of statistics now. Maybe I'd better go and learn all these sort of foundational stuff, mathematics and theory and all that stuff that all these professors know. And John looked at me and went.
So Jerry, you had with Leo had an early life with trees, right? And you wrote the card book with Leo and Richard Olshan and Charles Stone.
Yes.
And for a while, certainly when we were graduate students, trees, was this this non-parametric way of fitting regression functions and did feature selection, everything like that. It was it was an exciting tool on the block, a new tool in the toolbox. And for a number of years, people did a lot of research in trees, but then trees kind of started taking a back seat because there were more powerful machine learning techniques that came around. And then comes the boosting work and your gradient boosting paper and Leo's random forest paper, which built on trees and made these powerful and automatic tools. So this, as you said, this kind of happened in the early 2000s, right around the
I would say the middle 90s.
Yeah.
Middle 90s to 2000.
Yeah. And the interesting thing to me now is that both gradient boosting and random forests are still extremely effective and popular tools today, in spite of the fact that machine learning and neural networks and deep learning has progressed, made enormous leaps and bounds. These two tools are still persistent today and very popular.
Well, they're tools for data analysis. The tools that the machine learners are building are actually not for data analysis, but for pattern recognition. that was a field before I was kind of in as a physicist, pattern recognition, and which is somewhat different than data analysis, because in pattern recognition, the intrinsic noise level is very low. If you have, if you could come up with the right the right model, you could do perfect. And we know that because people can look at a picture and perfectly tell whether it's a dog or a cat every time. So there is an algorithm that can do it. So the issue is one of what we call bias or representational bias, getting a complicated enough algorithm to do it, and we can make huge models because there's no issue with noise. Plus, they also have huge data sets, and the antidote to noise, of course, is more data. So, but I think it's a different business, and where tree-based methods have excelled is in tabular data, which is data very different than the kinds of data they're dealing with, I believe. And that's why trees and methods based on trees, like boosting like land and forest, have dominated the tabular data.
But I guess in contrast, signals in images are really places where neural networks excel because they take advantage of the structure of the features, right? They're not tabular, they're rather.
Well, yeah, the thing, yes, that's the key, because in tabular data, the name of the variable contains no information.
Right.
It's just, variable 1, variable 2, variable A, color, whatever. Whereas in time series like problems or image like problems, the name of the variable, namely this particular pixel, contains information about its relationship to other variables, just its name. And that's a very different world in tabular data that we're kind of used to in data.
Yeah.
The other story I'd like to tell about Jerry is like how we often come into our offices and say, "You guys have 10 minutes?" Or "Sure, Jerry." And I remember this happened. We were both visiting Bell Labs way back, I don't know, late 80s or something. And Jerry did his, "You guys have a few minutes." And of course, Jerry's few minutes always ends up being at least an hour, and sometimes two. And I remember we had this discussion at the blackboard, and it was so complicated. And at the end of it, I thought, I'm completely confused. And you just said, "Thanks, guys, I really clarified it." And then I think you must have gone and written a paper, but like, you have a way of sort of getting clarity out of confusion, I guess.
Sometimes, not always.
Yeah, I remember we had lots of those discussions when we worked on
GlimNet, for example.
On GlimNet, yes, exactly.
Yes.
With GlimNet, you'd come into our office and say, "Guys, I figured out a way to save like 5 microseconds or something in this loop." And we go, "Jerry, we're too busy here." And then at the end, when the package was all done, it was like lightning fast.
Yeah, that's slightly stretched my programming talents. I still have nightmares about the Cox proportional hazards model. Programming and doing that one in the context of GlimNet. It's a hard one, and numerical issues and other things. But eventually got it working.
So what is this is sort of going off topic now, but what are some of your ideas, papers that you think should be more known and appreciated and used?
Well, gosh. The gradient boosting one that certainly not the paper with which I felt I had the most ideas or had the cleverest solutions, but it was the one that caught on, but it didn't catch on immediately. I mean, it sort of came to flower at the same time as support vector machines, which were, you may remember, very, very popular back then, especially among engineers, and random forest has been around for a little while. So it was kind of there. The thing that sort of put it on the map was due to Chen, and I forget Gerstern or I'm not sure. Yeah. They did XGBoost, okay, which there was a nice implementation of it in R done by Greg Ridgway, but XGBoost really enlarged it to really big problems, and I think maybe the GPUs, I'm not sure. But anyway, it was a very fast implementation, had lots of conveniences. That was one thing, and then Kaggle.
Right.
because people started using XGBoost and other and cable competitions, and it kept winning the competitions, and that's what put it on the map.
Mhm.
I mean, people have endless discussions about whether random forests are better than support vector machines, and people present their cherry-picked examples and stuff, but in these competitions, there's no excuses.
Yeah.
And so it seemed to do very well there. I think it won in one stretch over half of the competitions. That one
Wow.
single procedure.
Okay.
The winner of the competition, that's what they had used. And considering all the other techniques there are that can be used, so that gradient boosting owes a huge debt to XGBoost. And now there's later ones. There's Light GBM, and I forget there's another one that's very popular.
And it emphasizes the importance of software, right? Which in our profession hasn't always been appreciated, right?
Yes.
Yes.
if there's no program to execute it, it doesn't exist.
There might be a theorem that shows it's asymptotically correct, but
That's right.
you can't analyze data with theorems, right? So,
That's true. Well, it depends what you define as data. I mean, back in the day, when you said data, you meant let X be a random variable drawn from an IID normal distribution. There's my data, and now I can do the math.
how about prim? That's always been one of my favorites, been pretty much unknown because maybe there isn't.
Oh, you mean the one I did with Nick Fisher?
Yes.
Or the graphical thing that was done years ago?
No, the one with Nick Fisher.
Oh, yeah. I hadn't thought of that. Yes, I really liked that paper, and I thought it had a few good ideas in it. I was kind of surprised that it didn't really go very far.
Well, there's no good software. There you go. I mean, really.
Yeah, that's my fault. I did, of course, program it. I had to, but I never put it in. Yeah. Also, I think it's been. I think graphical analysis in general, which I was very interested in in the early days, what I did with John Tukey and others, and things, have not really made the impact that I thought they would. And I consider the prim thing kind of that. It's an exploratory technique. It requires patience on the part of the user and a fair amount of intelligence on the part of the user. Whereas if you have, something like gradient boosting or a random forest, you just put it in and you get an answer. And so I think, the idea of, I mean, John Tukey used to say that data analysis was detective work. And sort of the idea of being like a detective and carefully nuancing and trying to investigate what the data is doing.
Yeah.
It seems to be less in favor than sort of these big automated procedures that crunch, 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 and then turn out a result.
Well, it's hard to publish. It's hard to publish the results of a detective search, right? Say, I did this and I did that, right?
Well, yeah,
it's the big thing.
in academia, yes, that's a problem. But I think in in industry, I would think that would be kind of important. There you really want to get the information from the data. I mean, the data is just not an example to illustrate your algorithm. I mean, people really want to know the answer.
Right.
But it takes, I think, a lot of skill, and more important, a lot of experience to be able to do detective work on data. I mean, Tukey was good at it, but not everyone is.
And was it also, I think you told me that Tukey he'd have 100 ideas, 99 would be crazy, but one of them would be gold. Is that right? But you had to work on all of them to find out which was.
He was an amazing man. I mean, to understate the point. I learned that he was essentially my first teacher in statistics because he and I came to SLAC at the same time.
Yeah.
I was always impressed. I used to go to lunch with him every day when he was here, and usually he'd invite someone else that he knew to lunch with us. Not necessarily we would eat in the SLAC cafeteria. Someone from the biology department, from the medical school, from engineering. And what amazed me is that he they were discussing things. He could discuss any kind of engineering as good as that kind of engineer. He could discuss biology as good as any biologist. He knew all about everything. This is an amazing guy.
Well, I remember a graduate student I knew, a statistician in Toronto who was at Princeton as a graduate student when Tukey was active there. He said there was this department seminar, the most complex mathematical probability seminar by someone from Moscow, right? In the big room, and he's at the back, going through Fortran output, right? Not even appearing to even, and the whole audience is completely confused. At the end, are there any questions? He's got his hand up. Oh yeah, and he asked something about sigma fields, and it was just like.
And he always used to say that every time I went to a lecture with him, he always sit in the back row and pour over computer output. Those days, computer output was on paper output. And he would pour over it. Well, and then you're right, ask questions that I didn't understand. You know, it was all over. Yeah, a lot of stories about John. He was an incredible guy.
How about stories about Leo? He was fun. We used to
Leo was an incredible guy too. Different way, but incredible guy. I worked with Leo longer. I worked with Leo continuously at one spell for 10 years, or thereabouts. And then we stopped working together. Leo notified me he didn't want to work with me anymore.
Really?
That's not unusual. Everyone he's ever worked with, it always ends up that Leo ends up not liking the person. Not that the person that I always like Leo whenever, you know, and that has happened with everyone that's worked with him. Chuck Stone once told me Leo and Chuck Stone collaborated a lot, you know, before he collaborated with me. And he actually wrote Chuck a letter saying, I do not want to collaborate with you anymore. A letter. So we collaborated for about 10 years, and then there was about a 6 or 7 year hiatus. And then he called me up one day and said he wanted to collaborate with me again. And so we collaborated up until, I don't know, that's when we did the multiple response paper in the middle of.
Well, the card book, I think there's quite a story about how that almost didn't happen. The card book, right?
The card book. Well, it was Leo's idea to write a book because he said we never get this published in a statistics journal. Okay, so we have to write a book. And he was collaborating with Chuck Stone. Leo, as you probably know, resigned a full professorship at, I think, UCLA. Mm-hmm. Because he didn't like what he was doing and wanted to do applications. He was a famous probabilist, or as he used to say, probabilist. Yeah. And he wrote apparently a classic text on probability, and he's well known for that. But he wanted to do applications, so he resigned his professorship. He went to consult for a company, technical company down in LA. And that's when I met him. He was working at that company. And I'm sorry, what was the question?
The question was, you told me this one, the card book. Is it
the card book, yes.
Leo and Chuck.
He was working with Chuck on card. And I was totally separately, not knowing anything about his work. I'd been working on it here when I was at Slack. I had been collaborating a little bit with a fellow named Larry Hastie. And we were developing, and it was surprising how similar they were. So at some point we were informed we were working on the same thing, so we got together. And we both explained our procedures, and they were nearly identical. So we decided to jointly write a book, the four of us. So that's I'm sorry, yeah, the four of us, him and Chuck and me and Larry. Later on, Larry kind of dropped out. He didn't have the time, and he was interested in other things. And then Richard joined us because he was working at a medical school at the time, and had some interesting medical data that we illustrated with, which I think ended up in the book. Plus Richard also collaborated with a fellow named Lou Gordon and did a lot of theoretical work on trees, namely the consistency, asymptotic consistency of trees. And so on. And I think that's an interesting story. When I first came to Slack to head the comp group, Gene Golub was in the group half-time, because people in the because the group would support computer science professors selectively. And so Gene was in the group. I got to know Gene. But then Gene was going away on sabbatical, and he was afraid that if he just took off, the position would evaporate. So he wanted to see something fellow. And he said, yeah, I know a really, really smart guy in the statistics department who would be ideal for this position. It was Richard. And so I talked to Richard, said, yeah, fine. So we hired Richard for that year. And that's when he asked me, what was I working on? I explained one of the things was this tree business. We got quite interested in it. And of course, Richard was a powerful theoretician. So he went to work on the theory. And I think that really helped, certainly helped us in the statistics world.
And did that foursome that wrote the book, did that collaboration go well?
Smoothly?
That collaboration.
We,
No.
we
Again, Leo comes across often is this very mellow, like easygoing guy. He's not. He's a very intense man. He has, I wouldn't call it a facade because that's the way he is when he's like that. But he also has an intensity, and he and Chuck used to go at it, namely in terms of Chuck wanted to emphasize the theory more. Leo, in fact, yeah, at some point, I was kind of the arbitrator. Chuck wanted more theory. Leo wanted more applied phenomenological approach. And so I said, okay, let's write two books. First half is data and the phenomenology, and then the second half will be the theory. And that's that, at least for a while, solved the problem. But yeah,
I think it's fair to say you were the most easygoing member of the team.
Which is a low.
We can say that because there's no one to contradict us.
Well, that's true. Sadly, that's true. Yeah. I don't recall any major disagreements. I mean, when I was working with Leo alone, as you say, if that's the way you want to do it, let's do it that way. What the hell? I never had a strong insistence on anything.
So was the Carp book in a period where Leo was friends with you again or not?
Yes. Oh yeah. No. We started working together in the late 70s.
Okay.
And the separation didn't occur until the mid 80s. So
the book was written in the mid 80s, right? But
no, well, yeah, but I started working with him. I met him in 77, I think. And another story about Leo. Sorry about this. Leo can be thought of in some sense as the father of data science because he organized. He was always in, that was his thing, was analyzing data, and that was important, much like John Cooper. So he organized this conference in Dallas, Texas in 1977, I believe. It's called Conference on the Analysis of Large and Complex Data Sets. He invited everyone. I mean, Bill Cleveland was there. I don't know if John Chambers was there or not. A lot of the quote, people who are interested in data at the time were there. Okay, and there are a lot of stories I can tell you about that. There were gunshots in the motel. There were all kinds of interesting things. But one day when I was walking down the hall, and Leo stopped me. He says, "Jerry," he always, whenever he talked to me, he done a sentence. He would always say Jerry, and then whatever he wanted to say. So he said, "Jerry, as you may know, I'm running for the school board in Santa Monica, and I desperately need the accreditation of the Democratic Party there. And so they're having a meeting there, and I've got to go there and make a presentation and talk to them." Okay. But then he said, but that's tomorrow, and tomorrow I'm supposed to give my talk here. So he handed me a pile of transparencies. Said, would you give my talk tomorrow? I had no idea what he was going to, and I had visions of going out on the town in Dallas that night. Back to my room and spent the night studying his slides, trying to figure out what he was doing. And then I talk about it the next day. And he did get the support of the Democratic Party, and he did get on the school board.
All right.
But I just handed Trevor a note saying I no longer want to work with him. So, see if that works.
Rob gave me a note. I no longer want to work with you.
Yes, sometimes if well, actually, I don't know why in my or in Chuck says either, but I don't know what I did that made him feel that way. Maybe I part of it I think was he was going off in the random forest, which was his thing, and there was no reason for me to be angry. Maybe he just wanted to devote his time to that. I don't know.
Anyway, it's been a lot of fun talking to you, Jerry. Thank you for doing this.
Already?
Yeah.
Okay.
See you soon.
As always, it's been a lot of fun.
Yeah.
Okay. Take care, guys.
Thanks, Jerry.
Thank you for having me.
Okay.